Okay. Can you guys see my screen? Because it says on my end that my screen share is paused.
Yes, I can see you.
You can? Okay, great. What the? Where'd it go? Okay. So you guys can see the slides, right? Okay. All right. So basically, what we're going to be going over today is assemblies. What the heck is going on? Why is it not letting me present? Okay, what we're going to be going over is like assemblies, and a little bit on like motion studies. So how to animate stuff and how to actually see what you're doing work in the software itself. So, does anybody know what an assembly is already? Like wants to explain what an assembly is?
Isn't it just like one big like part, and then within the part there's like a lot of different like parts, and
Yeah,
there's different drawings for it?
precisely. Yeah. So you can think of an assembly as like a system of parts. So whatever you CAD, you can put it all in an assembly and then see how those individual parts interact as a whole. So yeah, an assembly is basically a whole and consists of a bunch of different parts. So our plan of action today will be introducing assemblies to you. What are they? How do we create them? And then I'll do an example. Um, First, I'll just explain like the different types of mates that exist. A mate is basically the way we describe the connection between two different parts. Um, and then for motion study or like for kinematic stuff, and Onshape has a very nice animation feature. So we're just going to go over that. SolidWorks is the three types of different motion studies, but yeah, we're just going to go over that one thing. So in a nutshell, what are assemblies? Assemblies are basically you put together a bunch of different parts to create a final system, or in this case, a final part, whatever you guys want to call it. It generally makes sense to me to refer to it as a system because it's like thinking about the interaction between different parts. And the way you actually connect parts together is by using what we call mates. And mates are basically what tells the CAD software the interaction between two different parts, or it tells the software how to connect two different parts. And just a reminder, whenever we like work through any examples, please do make sure to follow along, as that'll help. Any questions or doubts that come up, you can ask them right away. All right. For Onshape, quick gist: your mate options appear in the toolbar as previously. You'll note that there's many different options, but we'll just focus on several like main ones. Yeah, when you're selecting a mate, Onshape basically joins things depending on this thing called a mate connector, and that's just a point of interaction for the mate itself. And then the end goal is to create a system of mates that represent accurate movement. So whenever you create a part or whenever you create a system, you want to make sure that the movement of the system is as you expect it to be and not like just something totally random or out of the blue. So yeah. Okay. We'll move on to some assemblies later. But basically how I want to do this is by way of an example. So I'm gonna share a link in the chat, and I would like all of you guys to make a copy of this document in your Onshape, so that we can work on the assembly. It's just, yeah. Let me know if you guys are able to access the link. There should be a make a copy to edit button at the top, and then you can just make a copy. Okay, copy here. All right. Give me a thumbs up when you guys are done copying the part, and have a screen that looks like this where you can see everything. Okay, I'll give you guys 30 more seconds.
For some reasons I cannot save. I copy And a document's name, it says whatever, and then I just can't click copy here.
There should be like owned by me. That should be a category for you to like
Oh, okay,
press
okay.
on. Yeah, press on that and then you can make a copy.
All right, cool. Thank you.
Yeah. All right. First things first, you guys should be pretty familiar with this menu, right? It's just the menu of the part studio. We've been looking at this for the last 2 days. We're gonna look at something called an assembly. If you guys go down in the tabs, you'll see something called assembly one, right? And I'll just also explain how you can make a new assembly. Although you have assembly one over here, the way you can make a new assembly is just by hitting insert new tab and then hitting create assembly. That's how you can create a new assembly whenever you need to. So just keep that in mind. But right now we're going to navigate to assembly one. And I'm going to explain some of the different options for mates that we have in Onshape, which are right here in the top corner. Not top corner, just the top toolbar. So real quick, I'm gonna explain to you what a fasten mate is, and then a few of the other mates. So a fasten mate is essentially, um, suppose you can think of a fasten mate as like a drop of glue. Like if you put a drop of glue on something and then you join another part to it, that part is not going to move or not. It's not going to go anywhere, right? It's not going to be able to rotate. It's not going to be able to move. It's not going to be able to slide back and forth. It's fastened to that particular point. So basically, a fasten mate is something that removes all the degrees of freedom between two entities. So yeah, I think the best way of it would be to think of it as a drop of glue. Yeah. A revolute mate is essentially a mate that helps, that allows rotation along a certain axis. So if I add a revolute mate between 2 points, I will be able to rotate that object about that point which I've kind of mated it to. And then that's essentially how I'll be able to rotate it. Slider mate is similar in essence because it allows your part to slide back and forth along an axis. That's basically what a slider mate is, and it doesn't allow for any other degrees of freedom. So that's just the only degree of freedom that it allows for to slide back and forth. And then revolute allows for rotation, which is basically pretty straightforward. Cylindrical mate is basically what combines slider and revolute, and then it turns it into a cylindrical thing. So there's 2 degrees of freedom. There's your axes of sliding, and then there's also your rotation along the axes of sliding. So those are 2 different degrees of freedom you get. And then a ball mate is whenever you have a cylindrical structure that you're trying to mate in a cylindrical thing, and it allows rotation across the X, Y, and Z axes. If you guys have like experience with statics, just like ball joints and stuff, and that's basically the same thing as this. Yeah, it's just a ball socket joint. Yeah. Okay, and the last one that I kind of wanted to go over, which is really useful, is tangent. Basically, in Onshape, you can mate 2 points with a tangent, similar to that of a sketch. You can also do you can basically mate 2 edges, or you can mate two sides using the tangent mate. So yeah, that's the last kind of thing I wanted to cover. I know that was like a quick explanation. So I think the best way to see this actually work out would be to just do an example right now. If you guys want to follow along, I would encourage that. But first thing we're going to do is whenever we want to insert stuff into like a part studio, or like we want to insert parts into an assembly, we use this insert button in the top corner. So if I click on insert, I'll get the option to insert clamp parts. And then I'll get the option to insert the handle part. So you guys can go ahead and do that right now. Okay, let me know if you guys were able to insert things without any problems. Should be pretty straightforward. Yep. Yeah, okay, great, awesome. What you'll realize is like all of these things are independent parts right now. So I can drag them all away from each other, right? Like They can all be separated into different parts. So what the goal is that we want to put all of these 6 different parts together so that they can behave as a clamp and Onshape, so that essentially can behave as a clamp and Onshape. Yeah. And while making an assembly, the first thing you want to keep in mind is essentially there should be a point of reference for everything that you should be able to reference everything to a certain point. So in this case, that reference point I'm going to set is the origin, which can be seen in your assemblies, right? So I'm going to take this bar, which is the thing that the client slides on. And what I'm going to do is when I click on the bar, I'll get this like, oh wait, let me exit from this. When I click on this bar, I'll get this like 3 arrow menu looking thing. And what I'm going to do is I'm going to click on the circle, which is the intersection point for all 3 of these arrows. I'm going to right click on it, and then I'm going to get an option to fix to or like to move to origin. Where is it? Move to origin. Yeah. So once I move, yeah.
Sorry, can you show how the arrows pop up again?
Yeah, for sure. So if you go onto the bar part or like any other part and you click on it on one of the surfaces, you'll get the arrows, the 3 arrows, like that.
And that's only by clicking on one side of the part, right?
Yeah, or like any side of the part. Yeah, correct. Yeah, the next thing I'm going to do is, like I said,
Sorry
I'm
to
going to click on. Yeah, go ahead.
I don't get it. I press what you say and I don't get it either.
What don't you get?
But I get what you're saying. I'm just saying when I press any surface on what you item you chose,
Yeah,
that arrow doesn't come up. Yeah, that doesn't come up.
that doesn't come up. Do you have the
No.
like SolidWorks controls?
I think is the sketch thing popped up?
Oh yeah, that's probably the first thing.
That happened to me. The same thing was happening to me as was happening to Jose. And I closed it and then I reloaded it and now it's gone and you can do it,
Yeah.
but I don't know how to get there.
Yeah, and that's
Yeah,
precisely
you have
correct. So
to you have to restore it again for it to pop up.
if you're in the insert menu, you won't be able to click on any of the parts. What you have to do is you have to drop all your parts in, hit the OK, and then you'll be able to click on all the parts. That's probably why it's not working for most of you.
Thank you, Lucia. Yeah, fix it. Thank you.
Cool.
Okay. All right. Is that working for everyone now? Sorry if that wasn't clear in the first time around.
Yes.
Yeah. Okay, awesome. So again, right click, move to origin, and then right click again. And you should get an option to fix. That's basically what we want to do. We want to fix this to a certain point.
Can I see that fix, please?
Yeah, could you do it again? I'm so sorry. I wasn't able to.
No, you guys are good. You guys are totally cool. All right, I'm gonna do that one more time. So basically, suppose my bar is at some random ass point. I click on it, and then I right click on the circle. I'll get an option to move to origin, right? That's the first thing I want to do. Then it's going to take those 3 arrows and move their center point to the origin. And then the second thing that I want to do is once again right click and hit fix.
Okay, got it. Thank you.
Yeah. Once I fix it to the origin, the part's not going to go anywhere because it's fixed to the origin. So that's basically what we want. And you guys will know it's fixed to the origin because if you go into your features on the side or your instances on the side, you'll see that next to rod 1, it says part is fixed. Yeah.
So does that mean like the part won't move anymore?
Correct. That means that the part is fixed to the origin. It's not going to move anymore. right.
Also, quick question: the origin should be in the middle of the bar, or it can be anywhere on the bar.
It's okay. It just has to be on the surface of the bar. We just need a
Alright.
reference point. Yeah. Okay. So now anybody who's familiar with a clamp knows that like that one side is supposed to remain stationary, which is going to be this side, and then this side is the one that's supposed to move back and forth, right? So for the stationary side, do you guys remember from the mates like which would be the most optimal mate to use in this case? Considering that we don't want this one to move around at all, we want it to remain completely stationary.
Is it like the glue option, like the first one?
Exactly, it's the glue option. So if I go fasten mate, it's precisely the glue option because we want this side of the clamp, we want it to stick to the bar without it moving around or having any degrees of freedom. So no rotation, no sliding, no back and like nothing. We want it to remain absolutely fixed to one side of the clamp. So precisely, we're going to use a fasten mate. Now, in Onshape, the way we mate stuff together is if you hover your mouse, you'll notice that these like 3 axes looking thing comes above it with like a Pac-Man face in the center. Basically, that's just called a mate connector, and you can lay a mate connector at any vertex that you see here. So like any point, which any vertex or wherever I want to make a mate connector, I can lay it. So in this case, basically what we want to do is we want the inside, we want this, where the hell did it go? We want this surface of the bar, right? We want it to be in contact with the bottom surface of the gap in this little stopper, right? We want it to be in contact with the bottom surface. So the two things that we want to be touching are the bottom side of the rod and the like bottom of the hole of the clamp, if that makes sense, right? So what we're gonna do is we're gonna just click on the bottom of the clamp right there and lay a mate connector in the center, and then as well as lay a mate connector in the center of the bar right there. And if I complete that and I try to move the left side of the clamp around, it should be totally rigid and fixed to the bar if it's done correctly. And it should look like that. You guys want to go ahead and do that?
After that, you just check it out and then you leave it as solved, right?
Yep. You just hit OK, and it should look like this when it's done. You can hit solve as well. But yeah.
One more time.
One more time, yeah, for sure. All right, so once again, I'll explain this one more time. So we want, in the clamp, we want the inside, like the bottom of this gap in the stopper of the clamp, so that the left side of the clamp, we want the inside of the bottom of this hole, like this surface on the bottom of the hole, this one right here. We want it to be in contact with this side of the bar right here. Right, that those are the two things we want to be touching in this assembly. So the way we're going to do that is, like even in real life, how would you join these two things? You would put a drop of glue on the bottom of this hole here, and then you put maybe a drop of glue here, and then you join them. Right, that's probably the most optimal way to do it. And that same thing goes here. So we're going to add our fasten mate. Think of it as a drop of glue, and we're going to add a fasten mate on this side as well, on the bottom of this side as well. And if we hit solve, if you want to hit solve, you can, but basically you just have to hit the check mark and it's going to join these two parts together if everything is done correctly. And if you put your cursor over and try to drag it away from the bar, it should not move around. It should be totally rigid to that bar.
And I could add a quick question.
Yeah.
For the other one, like the inside like sole is like empty. I don't know if I'm saying that correctly. Like for the other part, the one on the right that you haven't connected.
Yeah. Yeah.
How would we oh, it is. Wait.
Yeah, it's empty. I'm that's the exact thing that I was gonna go on to right now.
Okay. Sorry.
Yeah. No, you're totally cool. I'm happy that you're making progress. But basically, the other side of a clamp. Think about how a clamp works. Like a clamp, one side is stationary and the other one is able to move back and forth, right? Like any that's the way you would be able to clamp something, right? So in this case, we've designated this one to be the stationary side. So this one has to be able to slide back and forth, right? Right. So does anybody want to take a stab at what would be useful for this?
Slider?
Yeah, precisely.
Slider? mode?
Slider. Absolutely, yeah. Slider would be the best option for this. And when we add a slider mate, essentially you have to think about, or like when you add any mate for that matter, you have to think about which two surfaces do we want to be in line, or which two surfaces do we want to be in contact with each other. In this case, the same thing applies. We want this bar to reach the very end of this gap, right? We want this bar to go through the hole in this right side of this clamp and reach the very end of this gap right here, right? So what I'm going to do is I'm going to add a slider mate. Once again, put a mate on mate connector right here on this side of the bar. And the second mate connector that I'm going to put is on the outside surface of the right side of the clamp. Onshape is going to be a little bit of a pain right now, and it's going to be like, okay, you're hovering over a hole. We don't want to select that. You're not going to be able to select anything in there. So the way you do that is just by hitting shift, and then you'll be able to select it. Okay. And then if I hit OK, these two should be flush with each other. The end of the bar as well as the end of the orange bit should be flush. And I should be able to move it back and forth. Like that, like so.
You said we gotta hold the shift.
Yeah, you'll probably have to hold the shift while dropping the mate connector on the orange bit, because it just won't show up if you're hovering over a hole. But if you hit shift and then hover your cursor over it, then you'll be able to see the mate connector that you're after.
Starts.
All right. You guys comfortable with that, or should I do it one more time?
You do one more time.
Yeah, one more time.
Yeah, for sure. Once again, the two bits that we want to be flush with each other is, bring it right here, the outside surface of the metallic bar and this outside brim of the hole in the right side of the clamp, or like the moving side of the clamp. So what we're going to do is use a slider mate, add it right onto the bar, and then into the center of the bar. And then it's going to be a bit of a pain right now, and it's going to be like you're hovering over a hole. How are you supposed to add a mate connector then? It's going to go to the inside. But to view the mate connectors on top of the surface of the hole, just hit shift and drag your cursor down right above it. And then you'll be able to select that mate connector right in the center of the gap where the bar is supposed to go, and click it like that. And then once you hit check mark, you'll be able to slide this thing back and forth right onto on the bar. Yeah. Now, that said, what you guys
For me,
yeah.
For me, I cannot do it. I'm trying to see.
Okay.
So we just hit the shift once like that, or we just gotta hold it?
No, you have to keep shift pressed. Keep shift pressed. Then hover over the gap, then you'll be able to see it.
Okay, I figured it. Did you get it?
Yeah, I think I figured it.
Keep it pressed, and then you can zoom in, hover over it, and you'll be able to select the center like that. Otherwise it goes
You have
away.
to hover over the like orange part first and then go to the space.
Yep.
You hover where like one of the circles pops up, and then you press shift, and then you can drag it in the middle.
Yeah.
At least that's
precisely.
what worked for me.
Yeah.
Yeah, just select any of the like corner insides, like the top right where like he's like selecting. That makes
Yep.
sense.
Precisely. Once the mate connector shows up on the orange bit, I just have to hit shift and go down to the gap. That's basically how to do that, like these guys have been saying.
Mine is good, so I don't know.
And I had a quick question. Is it supposed to be tilted when it like attaches?
What do you mean by tilted? It's supposed to be
Like
it's
it's
supposed
not
to look
like
like this.
it's not like vertical, it's like slanted, like it's like this. That makes sense. It's not like this.
Okay. So yeah, that probably means that maybe one of your orientations are incorrect. So if I go to slider and then I like use this rotating wheel, I'll be able to change that here, reorient the secondary axis. And that is actually a very good question, because basically what happens in Onshape, what you'll notice is when I lay out a mate connector on any surface, so suppose I'm dropping a slider mate once again, right there, you'll see that there's 3 axes on the mate. There's a Y, an X, and a Z, right? And a red, a green, and a blue. Basically, you want these 3 axes to match up with the 3 axes on the mate connector you drop on this piece, like so that they line up exactly with each other. If those axes are inconsistent, you know, in the direction that is specified, then it's going to rotate in random directions, and we don't want that. So the way you can fix that is just by, number one, when you're doing the mate itself, just keep that in mind, that all axes are lined up the way that you want them to be lined up. And then if they're like rotated at a weird angle, or like the Y's and the X are rotated, you can just hit the reorient the secondary axis button to fix that.
Okay, and to reorient it, where you click on slider 1.
Yeah.
And do you flip primary axis? Is that how you do it?
No, you wouldn't need to flip the primary axis. Basically, if I flip the primary axis, it's gonna flip the entire part, and I don't want that. So you just have to reorient the secondary axis.
Okay, gotcha.
Yeah, for sure. Okay. All right, now the funny thing is here, like you'll see that the thing slides the way we want it to, but it slides too far, and it slides too far in both. It's basically sliding too far in both directions, right? So we need to make a way. We need to add some limits so that this thing doesn't slide away and doesn't slide too far. And the way we can do that is if we click back into our slider mate, we can hit the limits check mark, and we can add a minimum and a maximum. So if I make my minimum 0 and my maximum, like, I don't know, 8, and I hit check mark, I shouldn't be able to move it past anymore, and I shouldn't be able to move it past any point like 8 inches away this side either. So that's how I can add limits and constrain my movement. Were you guys all able to constrain your slider mates?
Is it okay if you show one more time, please?
Yeah, for sure. I know Onshape is a bit like disgusting when it comes to assembly, so like it's a bit tough to get the hang of. So don't worry. So basically, I hit slider. I can double click into slider, and then I'll have the option for limits. I hit the limits checkbox, and then I can put in the distances, the minimum and maximum distances. So I want my minimum distance to be 0 because I don't want to move past anywhere in the Z direction. And then I want my maximum distance to be like roughly 8 inches so that it doesn't move past this point right here. And if I do that, then my block doesn't move past 8 inches right here if I drag it, and it doesn't move past the 0 point right here if I drag it in this direction. So there's movement, and it's constrained in both directions. And the way you guys can kind of see it is if you just press the play button, and you can see the movement itself.
I had a quick question. So on mine,
Yeah.
it's like the mate features, it shows fasten 1, slider 1, and slider 2.
Yeah.
I was just wondering why like it shows up slider 2 on mine, but not on yours.
Okay, so I'm pretty sure what happened is after you add a mate in Onshape, it just prompts you for another mate. So you probably maybe slider 2 came up and you misplaced a mate or something, but you shouldn't need a slider 2, you just need one slider right now.
Okay, so I should delete
That's
that.
why. Yeah, go ahead and delete it. Basically, I'll show you what happens. If I put a slider mate in, I delete this one. And I put a slider mate in. Right? and then I hit OK, it immediately pops up with slider 2. So you maybe just misplaced the slider, but that's basically why there's probably a second slider.
Okay, thank you.
Yeah, no worries. And then I constrained it to 0 and 8, and that should help us constrain our clamp. So it moves back and forth on our bar without it exceeding anything. Okay. Second thing is if you right click on slider, you'll be able to select the animate option. This is just to see what our slider is doing. So you'll be able to select the animate option. And if you hit play, you'll be able to see the thing move back and forth and see whether it's doing the thing you actually want it to do. So in this case, we can verify that, our clamp is actually engaging in the specified motion, like it's actually doing the motion that we need it to do. So we can confirm that these mates are fine. That there's no problem with these mates. Okay. Is everybody cool with that? Everybody at this point where they can see their one of their blocks sliding toward the other one?
I had a quick question. So
Yeah.
for me, the part that is moving, like it has a little bit of space underneath, like between the bar and the like very bottom of the part that is moving.
Yeah.
I'm not sure, like it's not fitting like yours. I'm not sure. I don't think it's like I assembled it wrong because
No,
it's
take a look.
perfectly like.
Take a look. Take a look. Yeah, there's gap on mine as well. So it just depends on the end value that you put in. I put in 8 inches, which is like almost at the end, which isn't exactly at the end. But yeah, don't worry if there's a gap. It's a gap between the two orange blocks, right?
Oh no! Between the bar and the bottom of the part that is moving, like that rectangle thing.
Yeah.
That is moving toward it. Yeah, like very bottom of yours is like fitting. Mine has a gap in like bottom of it.
Okay, so
like
maybe you misplaced like a mate connector or something. Just make sure that it's in the center of the gap and the center of the bar. That could be an issue.
Okay.
Yeah. Okay. Next out of the animation, and we can move on. So now we're gonna assemble the handle for the clamp. I'm sorry, I'm blanking. I blanked there completely. But yeah, basically, to assemble the handle, we're gonna put a fasten mate in between these two because we want this to be glued into the inside of this. Right? So you guys can go ahead and add a fasten mate between the red. So I'm gonna do a fasten mate on the bottom of the inside of this red handle. And I'm gonna do a mate connector on the outside of this blue circle right here. Yep. And I'm gonna hit OK. And then I should have like a handle connected to that blue portion. You guys let me know if you guys are able to get along with that fine.
So what you do is, what you do is you select the midpoint of the red object, and then you select the bottom point of the blue object.
Yeah. Yep. Exactly. Once again, you can think of it as like adding a little piece of glue. So like if I were to add a drop of glue, what two surfaces would I add the drop of glue on so that the red handle and the blue like piece can fit within each other flush, like in a flush manner, right? And then the way basically where you would add the drop of glue is on the bottom surface of this one and on the bottom of the inside of this red one right here. Right? And that would allow us to constrain these two to each other. Okay. Right. After we're done with that fasten mate, we have this rounded tip right here. And we have this rounded socket right here. So that said, does anyone want to guess what mate would be useful in this case?
Is it like the cylindrical one? The one
Not
that-
exactly the cylindrical one.
Hmm.
So the cylindrical one allows for like 2 degrees of freedom. So it has ability to slide and ability to rotate. In this case, we have a socket which is spherical. No, not quite. Close though, close. So if you guys remember the ball mate, essentially the ball mate allows for rotation on the X, Y, and Z axes. So there's like infinite degrees of freedom essentially with these, with this mate. So what we're gonna do is we're gonna mate the inside sphere of our little platform to the sphere of the little blue part. And the way we're gonna do that is the way I'm gonna do is just click on the outside sphere and click on the inside sphere, like this dome looking thing, like that. And when I finish that, it should look flush with each other. And if I hit the play button, I should be okay. Yeah, it should rotate like that.
Is this
Like
supposed to detach from the orange object? Like just like like the
Yeah.
glue basically like went away?
Yeah, that's totally okay. It's because the orange object is not actually constrained to anything. That's why it's doing that. But yeah, I'll show you a better way of how to visualize it in a quick second. But yeah, once your ball mate is done, it should look like that, and should be no problem. And like I did with the previous one, if I go to ball, yeah, it's all good. If I just take my cursor and I rotate this, it should rotate like so. It's fine. Okay. So now the reason the blue thing is also rotating is because we haven't constrained the handle yet. So now the last step of completing this assembly would be to fasten that as well, right? So what we're gonna do is the only place that we can actually add this handle is through this right here, like in a clamp. And the 2 surfaces that we want to be like in contact with each other in this case, if we take a look at the handle, we see this larger surface over here, right? And we see this surface over here. And the maximum distance you would be able to kind of use your clamp is if these 2 are in contact, and then that would be at its maximum distance, right? So anybody want to have a stab at which kind of mate would help us not only move this handle back and forth, but also rotate it?
Slider?
Yeah. Not exactly slider, but part of it is a slider. This one is going to be a cylindrical mate, right? Because we not only want it to rotate like a screw, but we also want it to move back and forth. So in this case, we're going to use a cylindrical mate. And the 2 mate connectors that we're going to draw is, once again, the mate connector at this edge over here in the center of the circle. And the second mate connector is going to be at the bottom of this blue part over here, right? Like there, right there. And then we're going to hit check. And we should have a part that is moving back and forth. Like that. Yeah. And there you go. We should have a completed clamp. Oh wait, funny. We don't have a completed clamp right now. You see we have a bit of an issue here as this thing is sliding back and forth way too far, much more than necessary. So once again, we'll have to constrain and add some constraints to the cylindrical cylindrical mate. I'm gonna do like 0 and 3. That should be good enough, I think. Maybe the other way around. You just have to play around with the numbers until.
Could you show you attaching it one more time?
Yeah, for sure. Yeah, there we go. Okay. Yeah, basically the way I attached this handle is first I thought of the two surfaces that I want to have in contact with each other, right? And that's where I'm going to drop the mate connector. So in this case, the outer brim of this blue mount over here should be in contact with the outer part of this orange mount over here, this orange bit over here. So I'm going to drop a cylindrical mate on the center of that hole right there, and it should look like this. And I'm going to go hover over that blue mount right here, and I'm going to hover over the outside brim or the outside circle of the blue mount, and it's going to display mate connector right in the center. I'm going to add one right there, and if I check it off, it'll very nicely mount everything like this. Now, what I can do is I can add limits, because currently the limits are completely messed up and it's going way further than we wanted to, like so. And that should make it so that it works the way we want it to work.
Can I just see the limits that you put?
Yeah, I just did -3 and 0. Okay. That said, I can now animate the cylindrical mate to see. Why is it not working? 3 inches, sorry. Start value should be -3. And the end value should be 0, and then it should animate. Okay, it doesn't want to animate. So what we're just going to do is we're going to go to cylindrical and just hit the play button. And yeah, I guess that works, right? Because it's rotating and sliding back and forth. So yeah, we have a completed clamp of sorts, which has a functionality that we wanted to have. Are there any questions?
Yeah, I got a question. So when you connected, when you did the last cylindrical mate, and then you connected it to the actual clamp itself, right? Or like the bottom part. How did you get it so when you move the orange, it also moves the whole thing? Because right now mine's not moving. Like the handle or whatever, that part's not moving. Just only the orange thing. Or does that default just do that?
It should default just do that. If you grab on the orange thing, you should be able to move it back and forth like this. On that, and then they should move back and forth.
Oh wait.
It's like if you pull it, like if I suppose I have my clamp in this orientation right here. If I pull the handle back all the way, it makes sense that it's pulling the orange bit as well. But now once the orange bit reaches the end, it's just going to extend the clamp all the way.
Okay, that's weird. Mine's not. Let me check.
Okay, yeah. You should be able to move the orange bit as well as this bit right on top as well.
Yeah, could you do the mate one more time?
Yeah. Okay, so if I have a cylindrical mate, so I'm going to do one right now, cylindrical mate. I'm going to think about the two surfaces that I want to have in contact with each other. So which would be the outside surface of this blue bit here and the outside surface of this orange bit right here, right? If I drop a mate connector right here on the outer brim of the blue bit, and I drop a mate connector right here on the orange one, and I hit O check, it's going to essentially complete the mate like I wanted to.
And I could add a quick question. So
Yeah.
for the animation for cylindrical one, the only thing that rotates is the sliding clamp, not the tool. That makes sense.
Okay, so slider one, you said, right? If I animate this, is that what yours looks like?
Sorry, I'm at. Play that.
Or
Sorry,
cylindrical
I'm
one?
cylindrical one, because that's the
Okay.
one that you changed.
Yeah.
Yeah, I have the same. Yeah,
Same thing.
there's 4 values. I did 0, 3.
Right here.
Yeah.
All right, let me do that again.
But what moves is the slider.
Yeah, that's fine. It's because this cylindrical mate is applied to in between the blue thing and the orange thing. That's why it's just the blue thing is moving. Yeah, Onshape is just stupid sometimes, and that's a great demonstration of why.
Okay, I got you. It's probably like where I selected it for the slider or something. That could be the reason.
I'm pretty sure the reason is just because Onshape can't display everything moving at the same time for some reason. That's why it just displays the blue bit. But as far as the blue one is moving back and sliding back and forth as well as rotating, you're fine.
Okay, gotcha. Thank you.
Yeah, no worries.
Etiquette, sorry, I know you just did this, but can you just show exactly what you clicked on when you did the cylindrical mate, like the two mate connectors that you chose? Because I swear I did exactly what you did, but they just not like sticking together.
Okay, yeah, no worries. First I'm gonna hit cylindrical mate. Then I'm going to select the outer circumference of the orange one. That's immediately going to drop a mate connector at the center of the circle where I wanted to. And I can verify that it's in the right place by panning around it. So the outer circumference of this circle, if I click on it, it's going to drop a mate connector right in the center. Similarly, if I click on the outer circumference of this little blue nub right here, right there, I click it, the outer circumference, and then I hit solve, these two should be in contact with each other now. And that's what we're going after. Cool.
Yeah, I'm good. I don't even know what I was doing, but thank you.
Did that work out?
Yeah.
All right, sick. Okay. Yeah, that's it. That kind of completes our clamp. Yeah. If you guys want to go ahead and like take a 10-minute break, we can get back to this.
Sorry, can you do the animation for slider one, just real quick?
Slider one?
Yeah. Oh, okay. That one. Okay. It's just gonna move each part. Okay.
Yeah, like it should look like this.
Oh, yeah. That's how did you do that? Yeah.
Okay, so the way you do this is you go to slider one.
Mm-hmm.
You go to animate.
Okay.
And you add your start and your end values, which are the same as the limits we put in earlier, and then you'll be able to engage the animation like that.
Got it. Okay. Yeah, that's what I was looking.
Yeah, that's a much easier way of looking at it. I agree. Okay. All right. Yeah. For some reason, it just doesn't want to animate the cylindrical mate, which is so weird. Let me try to determine why it's not doing that. Okay, I don't know. I'll figure it out. Anyways, if you guys have any questions, feel free to ask right now. Otherwise, you guys can have a quick break, 10 minutes, and we'll get back to attempting to assemble stuff in Onshape.
وقتی که از پشت میکنم
All right. We'll start bringing it back.
I had a question about
Yeah.
the limits. My handle, what is it? Like it goes through the stationary clamp portion.
If the orange one is extended like all the way down, is that when that happens?
Yeah, it's like there's a clamp and then it goes this portion, like that portion goes through it.
Like yeah, okay. So the way you can change that is just by changing the limits of the orange one. So basically, like is it looking something like that?
Oh no, mine it goes through it. Right,
Like
that
this?
there, like that. Yeah.
I mean, there's not much you can do about that, right? Because CAD won't know when these two surfaces are in contact.
Oh, okay, so that's normal.
Yeah, that's fine.
Okay.
That said, I do want to kind of clarify some things about the animation stuff because I feel like it was a bit unclear. So basically, when I click in a mate, suppose I click in the first slider mate. Now, actually, a better example would be like the cylindrical mate, and then I animate it directly within the cylindrical mate menu. It's just going to display how that mate is occurring with respect to not the assembly as a whole. So how I can actually animate it and see it properly is if I go to cylindrical, I hit animate. It'll give me two options. It'll give me to select a degree of freedom for either the rotation or the translational movement. Suppose I want to animate the translational movement and I hit play, then I'll be able to see it translating back and forth like so. I'll do it one more time. So if I hit cylindrical and I hit animate, and then I hit the degree of freedom that I'm trying to look at. So in this case, I'm trying to look at the back and forth motion. I hit cylindrical and then I hit play. I can see it move the way I want it to move. With respect to the entire assembly. And in this case, that's kind of what we expect it to be doing. So yeah, that works out. Does that kind of clarify some of the stuff about animations and seeing things move around? Yeah. Yeah. Okay. All right. That said, I have another example for you guys to try, maybe on your own. It is the universal joint. I'm opening my universal joint that I worked on earlier, and I'll show you how it looks like. So this is a universal joint. It has a couple main parts. How a universal joint basically works is it just changes. Well, it's mainly used for like rotational motion and converting rotational motion. So like if I have a gearbox or something, it's used in that application. Basically, this is what it is. It's a coupling joint, connects rigid shafts who are inclined to each other, and basically looks like this. So what we're trying to CAD is this little centerpiece, or what we're trying to assemble is that little centerpiece. So in this case, what we have given to us is this orange bit. I mean, not orange, yellow bit, golden bit, this gray bit in between. And then you guys will see that there's this dark blue one here and this blue one over here. So I'm going to send a link in the chat for copying the assembly. I'm going to go over a few things which might help in assembling, and then you guys can have a shot at assembling it. firstly, what the things look like. So there's a universal joint piece, which is this. And there is these three pieces. There is no assembly, so the first step would be obviously create an assembly. And the second thing would be to insert the parts. When you insert the first universal joint, you'll notice that it drops, or like it attaches to the connector, mate connector, which is already there. So if you do that, and I enter, I can, like the previous example, I can fix this part to that particular point. So now it won't move around. So always make sure to, whenever the first part you lay down, always make sure to fix it to that center point or whatever reference point. And then a couple other things you'll see are these three pieces, right? Yeah, the way they're joined in mine. The way they kind of join each other is like this. So the surfaces that are once again in contact, it's always good to keep in mind the surfaces that are supposed to be in contact with each other. Is, if I delete this, is this inside bit right here to this outside bit right here. So this, which my mouse is over right now, to this, which my mouse is over right now. And so that's faceted like that. And the entire assembly looks like this. So not many mates involved actually. So yeah, if you guys want to have a stab at this, feel free. Let me know if that was kind of clear maybe, and whether this, you guys can follow along with this. I'll leave this up here.
Sorry, do we move both to the origin or just the joint?
Just a joint. And then when you mate the black, or like the gray box to the joint, it'll naturally already be at the origin because there's a mate connector which is at the origin there.
Okay, and sorry, I had another question for the other joint. Like, do we like make like a second duplicate and then like add it to the?
Yep.
Yeah.
Yep. So yeah, what you can do is you can just insert universal joint components again, just delete this one and then keep these two.
Okay, gotcha. Thank you.
Yeah. Yeah, I will, once you guys have a stab at this, I will kind of go over some ways to optimize and like different tools that you can use to actually make the process a lot quicker. But right now, based on what we learned from the previous clamp, you should be able to replicate this joint right here. If you have any questions, just make sure to shout out. I'm right here to answer them. Also, I'm dropping the link for the slides in chat. Cool. Also, actually, did I mention this already? I should probably mention this right now. This will probably be useful. So, whenever you're doing an Onshape mate, the first surface that you select is always the point that's going to move, and the second surface is always going to be the stationary point. So in this case, like if I look at this joint over here, I want the rod to remain stationary, but I want this little blue disc to be the one that turns. So in this case, if I look at the ball joint and I play it, because the threaded mate connector is the second one I selected, it's going to be the stationary one, and the first one that I selected, which is the side of the ball disc, is going to be the one that moves around. Suppose I did it the other way around. Suppose I selected this. I'm sorry. Suppose I selected this first, which means now it's the point that moves, and then I selected this second, the inside of this second, which means that this becomes the new stationary point. And I play it. The rod is going to move around on the disc, which is not what we want, right? That's the opposite of what we want. So what we can do is just swap them around. Yeah. Wait. Yeah. And then that fixes. Wait, what the hell? Just do it again. So we want this one to be the one that moves around, and we want this one to be the stationary point, right? So that fixes that problem. So always keep in mind the second mate connector that you selected Onshape, the second one is always going to be the stationary point, and the first one is going to be the point that moves. Similarly, if we look at the cylindrical mate that we made last, we want orange to be the stationary, the orange mate connector to be stationary, and we want the mate connector on this blue one to be the mate connector that moves around. So in this case, our animation is going to look like this. But suppose it be backwards, the orange thing is going to rotate around the blue one, which is the opposite of what we want. So if we do it like this, and then we play it, that's going to do the other thing. It's going to be the other way around. So yeah, keep that in mind when you're doing your assemblies. What is the stationary point, and what is the point that moves around? Did that kind of make sense? Yeah. Okay. That should be pretty helpful, actually. I'm sorry, I forgot to mention that earlier.
I have a question. How
Yeah.
how did the assembly pop up again? Like inserting stuff from the very
So top right corner, top left corner, there should be an insert button.
I don't see that. Let me share my screen.
Okay, so yeah, go for it. Share screen.
It's kind of weird. So
Yeah.
where is that though? Like,
Okay, so first step is to create an assembly. Right now, you only have Part Studio. So if you click on the plus sign in excuse me, if you go to the very bottom of your screen, do you see, yeah, insert new tab, and then you hit create assembly. Down fifth option, yeah, create assembly. You'll see that assembly 1 is created. Now you can insert the part. So whenever you create an assembly, or like whenever you want to join parts, you have to create the assembly, right there. Now you can click check. Yep, and do whatever you need to do.
okay. Thank you.
Yeah, for sure. You're just sharing your screen, by the way, just in case.
I had a quick question.
Yeah, what's up?
So, the tool thing, like the box, what you're saying is that, like, for example, if you want to like fasten it, so like we make sure like none of it moves. Well, you, like, for example, the spherical one, the small spherical shape, the light green,
blue
I
one?
guess it's saying? Yeah, yeah,
Yeah.
yeah. That one would first be selected, and then you would select the box to connect it. But every time I do that, like it goes inside, it doesn't go outside of it.
Okay. Here, let me share my screen. I'll kind of go over that quickly. One sec. Okay. Do you guys see the joint example? Okay. So the mechanics of the joint, firstly, they're just supposed to be like this. The rotation like this, and then it's supposed to be able to move back and forth like this. So if I delete this part, it looks like this. This black box is able to rotate around the center of the yellow one. So that's the rotational mate, whatever, the revolute mate. And then the thing that these look like is like this. Basically, outside surface of the light blue onto the outer diameter of the larger dark blue bit here. And then the way these connect to the box itself, suppose I like insert a box and I delete this piece. I'll put these here. Right. Basically, the way I want it to connect here is this outer brim right here connects to the outer brim right here. So if I do a fasten mate and I do click the outer brim over here and I click the outer brim over here, it should just fasten right like that. And it should look like this.
Okay, so
Does that, yeah,
yes, so first connect it to the dark blue and then connect it to the box.
correct. Yeah.
Okay, gotcha. Thank you.
Yeah. Yeah. No worries.
I had a quick question. Can I build like everything on one side and then just like just basically like bring the whole thing to the center or to the origin or not?
Yeah, you can do that.
Okay.
It's just whenever you start your
'cause I can-
assembly, it's always good to have a reference
Mhm.
point because like later on when you made stuff to the assembly, you might get like problems that you didn't expect because they're happening due to a lack of a reference point. So it's always good to have a reference point to start with. But
You have to right click, right? And then it should be like an origin, no?
yeah, you don't exactly have to do that this time. I'll show real quick what the process is. Okay. So, like I said, if I insert the universal joint, it's going to insert it right at the origin to start with. If I hover over universal joint, it's going to insert it at the origin because it already has a mate connector.
Okay.
So if I just insert, oh shoot, I did it twice. If I insert the universal joint and hit check, then I can go on universal joint and just fix it to the origin. Now that's not going to go anywhere now.
All right, got it.
Yeah, got it.
Yeah.
Sick.
Thank you.
I'll be back in like 2 minutes. I'm gonna get a drink of water.
Anik, a quick question. So the corner, like of what the so I have like the gold metal machine, like when you like insert the dark blue,
Yeah.
is it like supposed to be like kind of, sorry, like the way I'm trying to describe it is like it's kind of like attached, like kind of like stuck in more. Like it's not like it doesn't have like more space to breathe, if that makes
Can
sense.
you share your screen?
Yeah, sorry.
Yeah. Yeah, no, you're chilling.
So I meant like if you zoom in, it looks kind of
Mm-hmm.
like, is this like a good way of how it should be like made?
Yeah, I mean, pan around it real quick, just a bit.
See, like right there is what I mean.
That looks like it's too far in, maybe. Something, there might be an incorrect mate somewhere. I'll just show you what it's supposed to look like one more time.
Okay, gotcha.
Yeah. Okay. One sec. Okay. All right. So just to recap, the blue one, this one mates with this one at this point right here, between the larger and the smaller circumferences. Right? So if I real quick do it like that. And then when I made it inside of this, right? This outer, right here, this outer bit, will mate with the outer circumference of the circle in the gray bit in here, like that. And this backwards, so I just gotta flip the axes and then hit OK, and it should look like that. Now, the last bit is I have to put it to this one, right? So if I do a revolute mate, I can put it like this. It's all, and it should look like this.
Okay, cool. Thank you so much. That's what I meant.
Okay, awesome.
And a quick question.
Yeah.
If it first attaches to the sides instead of to the top and bottom first, is that an issue that you have to like fix in the beginning? Or is it okay to
Sorry, I don't think I understood the question.
like is it okay if it's like attached side by side or like in the beginning, or should it be like up and down first? Sorry,
What
but
do that doesn't matter.
okay,
Because you can always just rotate the gray bit and then, you know, make it side to side as well. So that doesn't really matter.
Okay,
Is
thank
it rotating like along the X
you.
direction as well, or?
We're saying side by side, but top to bottom.
Yeah, because the like filled out bit should be on the top. The one without like the flat side should be on the top. Just make sure that.
Okay,
of that.
gotcha.
Yeah, cool. I'll give you guys like another 7-ish minutes to work on this, and then at 10:40 we can go over it.
Aniket,
Yeah.
this may be like a dumb question, but is there any way to make the animation faster or no?
Change the number of steps. You see how it steps like it says like 30
Gotcha,
100
gotcha,
steps or
gotcha,
something.
gotcha,
Yeah, if you
gotcha.
reduce the number of steps, it's gonna make it slower.
All right, thank you, thank you.
Yeah, no worries. I had like a quick question.
Yeah.
Can I share my screen?
Yeah, go for it.
Do you know how to flip that? This guy to outside?
Oh yeah. Can you open the
Sorry, you cut off maybe. Say it again, please.
Like open the previous fasten mate. You see the arrow? Yeah,
This one?
yeah. Okay. It's probably because that fasten mate is the previous, like it's probably fasten 4. Click on fasten 4. Now try. Yeah. There you can flip the primary axis that way.
What about the blue one?
Okay,
This
so
thing.
the blue one needs to be reversed, that means. So whatever is fastening the blue to the light blue, you need to flip that.
That's 5, I think. But I attached this
I mean, it
to
would be flipping if it was 5. Can you hover over like fasten 3? Like which one is this? Okay. Yeah, try flipping this one. Huh. Okay, it's not this one either. So whatever is fastening the dark blue to the light blue, that needs to be rotated or flipped.
Okay.
I couldn't tell you which one that is.
Oh, this guy. Do you know how to go back though?
Yeah, I mean just delete the fasten mates.
Okay,
Go back. So basically, yeah, basically the dark blue one needs to be rotated. Flip like 90 degrees. Whichever fasten mate that is, you just need to rotate it or flip it along its primary axis.
Okay, I'm just gonna delete it and redo it then.
Okay, yeah, that's totally fine too. Yeah.
Thank you.
Okay. That said, I will start going over this as well. And I will also like show you some stuff on how to optimize. Oh shit, I broke it. One sec. Okay, here it is. So how to optimize some stuff. So okay, here we have this, right? And I went ahead and fixed this part to the origin already, right? So now that's done. Now what I need to do is I need to import some more parts. So I'm going to import my joint components. I have this part and I have this part and I have this. Now this needs to go over here, but it needs to be able to rotate, right? And this black one needs to be on the top side. So if I do a revolute mate, select one of these mate connectors in between, select this right here and hit OK. I notice that I can rotate it like so. Now,
can you do that again?
Yeah, for sure. Give me a sec. Let me delete it. Okay. So this is right here. Now what I need to do is I need to somehow, oh wait. I need to insert these parts first. Oh shoot, that's too many parts. Insert this set of parts first, right? Then I have this box. I need to mate this box with this mate connector, right? So what I'm going to do is I'm going to do a revolute mate on that.
Okay.
All right, so that's going to be this one. Revolute this one with this one. Boom. That makes sense?
Yes.
And that revolves, right? That's perfect. Exactly what we want it to look like. Now, the next thing we're going to do is we're going to take, I'm going to delete one of these because I only need one of them, to be honest. I'm going to delete this, and I'm going to mate this one as I need to. So fasten the outer brim of this blue one, the outer brim of this light blue one, and hit OK. And now I have this thing, right? Now, what I need to do is I need to mate this to this as per like this, right? This is what it's supposed to look like. So I need to mate that blue thing to the gray thing. So if I go back to Onshape, I need to mate the outer brim of the light blue one to the gray one. So fasten this to this and hit OK. Now it looks like this, right? Now Onshape, whoever designed Onshape decided it would be a smart choice. Number one, to create something called a subassembly. So a subassembly is basically you take two parts, you create a smaller assembly with them, and it's really simple to do that as well. So if I take these two parts, which is the light blue and the dark blue one, can take them and I can right click and they should give me an option to move to a new subassembly. So within this subassembly, now it's just these two parts that are assembled together. Now, which is great for us. Now what we can do is we can use this thing called replicate, and it's going to prompt us with a couple things. By the way, this is how to optimize. So the way I'm going to do it is I'm going to make my two parts an instance, which is going to be a subassembly by right clicking and saying create subassembly. So I'm going to create a new instance. My instance is going to be that subassembly. And the faces that I want to duplicate this on is all four faces of this cube that I'm working with. So 1, 2, and my third face. And that's half the job done for us, right? Because now I have these 4 plugs on the gray cube and they rotate just like I need them to. Cool. Right? And that looks like what we need to look like. Now, the last step is adding this joint on the top, right? And we want this joint to be like turned 90 degrees. So what we're going to do is we're just going to use the mate connector here and do a revolute mate right to the center mate connector right here. As so. Only thing is this needs to be rotated. Oh, that's not right. My bad. Let me do that again one more time. So it needs to be in the same axes as well. So the blue axis is going outwards here. And yeah, there we go. And that completes our joint. That completes our joint. So we have movement in this direction. We have movement up and down. Now, the last step would kind of be to constrain the things that we want to constrain. So in this case, we need to constrain the rotation. So right now it's going to rotate 360 degrees now. Okay. So if we do like 0 and negative 90 and I don't know, 90, and we try to animate it, let's see what it does. So it's going to the bottom to the top, so that we need it to go like 0 to 180 or something. So if we go back and we go to revolute 2, we go 0 to 180, and then we hit animate. Now let's try that's doing what we wanted to do.
Is there a way to animate both of them?
No, you're only able to animate like one
One at a time?
mate at a time. Yeah.
All right, thank you.
Yeah, no worries.
Could you show that step again of how you attach the gold again? The gold part?
Yeah, the top gold one.
Yes, please.
Yeah, for sure. So the way I did that, is we see that there's like these central mate connectors, right? We want, if I just import the part again, I'm just gonna go ahead and mate the golden bit to one of those central mate connectors. Now I just need to make sure that that the axes aren't aligned and the axes are turned 90 degrees because I want the part to also be turned 90 degrees. So if I do a revolute mate and I look at the mate connectors here, I can see that the mate connectors that are parallel to this mate connector right here, this mate connector is parallel, has the y-axis going in the same direction, like the blue axis going in the same direction. So we need to select this one right here. And then this mate connector in the center. And then if we hit OK, that should solve our problem. Yeah. And of course, the last step would be to add the limits where necessary. Right now, we've not really added any limits. We've just kind of made it things so that we can have some motion. And let's see, that's a problem as well. Here we go.
Would you be able to show how you attached each thing to each face of the gray cube?
Oh yeah. Let me do that quickly. All right. So the way I did that is, so if we're in a new assembly, suppose we're in a random new assembly, we're starting the thing entirely again. If I enter the joint again, one sec. Okay, I enter the joint again, whatever. I fix it. That's my first step. Now the second step is the gray cube, right? And I have three little things on my gray cube. So first, what I did is I mated the dark blue and the light blue bit together, right? I mated the dark blue and the light blue bit together. Now, in terms of optimizing this, what you can actually do is you can take the light blue and the dark blue bit and from your instances, and you can put them in something called a subassembly. So when I create a subassembly, it essentially allows me to take these two parts and consider them as one part, right? So if I consider these two as one part, I'll be able to use a tool called replicate. So in this case, I'm going to move to new subassembly. I'm going to go ahead and mate this once to one of these circles in the gray cube. So I'm going to do a fasten mate, go ahead and fasten mate that like so, right? Now, Onshape has this great feature where what you can just take what you've done with one specific mate or one specific instance and you can just replicate it. So if I go to my search tools and I hit replicate, I can take that one instance that we just combined into the subassembly and I can do the same thing on all faces of the cube like that because they're identical. And that's how I replicate each of these blue bits on the gray cube itself. Does that answer your question?
That made sense. Thank you.
Yeah, no worries.
Could you show how you rotated it just one more time? Just like the animation, I mean.
Yeah, for sure. So this is my completed thing, right? Now, if I go to revolute, and then I hit animate. So let me do that again. If I right click on revolute and I hit animate, I can animate the rotation of this and I can like set the degrees as well. So if I do 0 to 180 degrees, which is the limit that I've set earlier, I'll be able to rotate across what I want to rotate across, like so. And the way I kind of did that is I first went to my revolute, I set the limit. You can set it to 0 to 180 or whatever works for you, to be honest. In this case, right now, it's going 360 degrees, and that's not what we want. So what we're going to do is we're going to make it 0 to 180. And then that still is not doing what we want, but it's okay. Because when we go here and we do animate, we can set the start value to 0 degrees and the end value to 180 degrees. That's our limits. And then we can just hit play, and then that's going to animate it as we want it to animate it. And we can see that it's not intersecting like the part at any other point, and it's just carrying out the action like we want it to. Did that answer your question?
Yeah, I got it. Yeah.
Okay, great.
It was good.
Great. Yeah.
Sorry, one more thing. If you were to select the top part of it, like if you were to like move it yourself, it shouldn't deattach, right? It should stay
No.
attached.
Yep, it should.
Okay.
So if I do anything with it, it should remain attached. Right now, it also needs the limits also need to be on the gray cube Revolut made, because right now it's intersecting itself when it's turning like that. But that's okay. We can always add the limits afterward. But yeah, nothing should come detached.
Cool. Thank you.
Yeah. Cool. I know that was fast. And Onshape is notorious for making assemblies. As convenient as it is for basically anything else, making assemblies in Onshape are so annoying sometimes. Lol. Yeah. What saves you a lot of time is the sub-assembly, and then replicating the part across all the faces. So I hope that kind of made sense. Yeah.
I'll
Yeah.
just rewatch it whenever you post a video.
Yeah, I know it was really fast. It's just there's a lot of
Fine.
material to cover, but
I feel like most of this stuff you just gotta do it yourself like a bunch of times anyways.
yeah, a lot of it is just practice, but yeah, it's always good to know what you can do to be faster at things. But yeah, practice. Yeah, I mean, if you guys like want me to make a supplementary video on assemblies, specifically like this example and the previous example, let me know if that would be helpful, and then you'll have this recording to refer to as well. Maybe
That would be
might
awesome.
help, or yeah, that might help clarify some things a bit. Yeah.
Yeah, supplement video will be really
For
nice.
sure. I got you guys. And I can give you guys some more practice if you want as well with like assemblies. That might also be helpful. Let me know if that sounds like something that interests you.
Are you saying like things to create example
Yeah,
wise?
just like examples to practice. Yeah, exactly. Okay, for sure. Yeah, I think the hardest part of CADing itself can be assemblies sometimes, because like they're just a little more abstract and harder to imagine. But then once you are able to understand them, I think CAD itself just becomes easier.
So quick question, can you just click on the replicate part? I wanted to see something.
Yeah, for sure. Yeah.
So replicate. So once we hit the replicate, okay. We get right on the assembly too.
Yeah. So do you want me to like run through the
Oh,
replication
I got it.
thing?
So, I did. I just wanted to like figure it out on my own. But yeah, if you can just show me.
Yeah, for sure. No worries, no worries. So if I import all the parts one more time, I gonna go ahead and delete these two because, all right, whatever. I'm just gonna leave them there. Cool. We're running out of time, but I've already made it like these two right here, right? These two are already like combined together. So what I'm gonna do is I'm gonna highlight both of them. To highlight them up here, and then in the instances, I'm gonna create something called a subassembly.
Yeah, I got that.
Right, subassembly. Move to a new subassembly. Now, when I want to duplicate the entire thing and like onto the cube itself, what I'm gonna do is I'm gonna do the fasten mate once. I'm gonna fasten this to the cube once, and then I can replicate everything using the subassembly. So if I do the fasten mate once right here like this, and I solve everything, boom, that's there. Now what I can do is I can use the replicate tool. So if I just go to the search bar for like search the tools right here,
yeah,
and I do replicate, right? Replicate. Okay. It's going to ask me two things. It's going to ask me for an instance. An instance is basically your subassembly, right? Because under instances, assembly number 5, that's my subassembly. So I'm going to make that an instance. And then the faces that I want to find the match in, or the faces basically that I want to duplicate this subassembly on, is just going to be these 4, or like the other 3 faces of the cube. Where did it go? There it is. Like that, and like the last thing is just like that. And that's basically it into like duplicating stuff. That's all that you need to do.
Thank you.
It's after 9.
Of course.
So you want to close up and then have everybody come back to the main meeting room because I have a few announcements.
Yeah, for sure. I mean, we're pretty much wrapped up here.
Great. Thank you.
Thank you, Aniket.
Yeah, for sure.
Thank you, Aniket.
Yeah.